Hello dear students, I am Samir Velankar. I welcome all of you to this video in which we will be seeing GATE 2006 question asked on the closure set of attributes. Now, in this question, we are given some FDs and we have to find out closure of the given question. Let's see. Let's check that following functional dependencies, check the question, following functional dependencies are given. AB determines CD, AF determines D, DE determines F, C determines G, F determines E, and G determines A. That means our table is going to contain the attributes A, B, C, D, E, F, G, if I am not wrong. Yes. Then which of the following options is false, they are asking. Isn't it so? Is CF plus, they are asking, is CF plus equal to what it is given? Is it true? A, C, D, E, F, G? Isn't it so? So the best way and the only way to solve this question is just to find out the closure of all these things given, isn't it? Like what will CF plus be? You all know from the earlier video, CF plus will contain CF, definitely. And now see the left hand side of these FDs given. Is any FD having C on the left hand side? Yes. C determines G. So as C is already there in the closure, G will appear in the closure, isn't it? G is also there. Is F there on the left hand side? Yes, F will bring in E, isn't it? And now notice G, which is already there in the closure set, G will bring in A. And now, as A and F both are there in the closure, observe A and F, I'm pointing them, both are there in the closure. A and F together will bring in D, the tick, I'm putting a tick on the FD. So it has brought in D, isn't it? Now you watch that D and D and E, I am pointing it out now. D and E both are there in the closure set. Then D and E together are going to bring in F. Check this where I am ticking, but F is already there in the closure set. So this is not giving us any additional information. Isn't it so? Now anything else that we can bring in? We have already seen C appears on the left hand side. C has brought in G. And G appears on the left hand side. G has brought in A. And the combination of these attributes, let's see whether this which is pending, all the FDs we have used, already I have ticked them. Does this which I am encircling is going to be used now? AB determines CD. Now we can't use this because AB, the left hand side, is not there in the closure set. A is there, agreed, in the closure set, but B is not there. So we can't pull out anything else or new from this. So the closure of CF is A taken in sequence, A, then C, then D, E, F, G. So A is correct. They are asking what is false, isn't it? Which one is false over here? And we have successfully found closure of CF, and closure of CF is really A, C, D, E, F, G. Let's find BG plus. Now BG plus is going to contain B and G. Now let's see, can B alone bring in something? Now, never on the left hand side, anywhere in all these FDs, on the left hand side, B is there alone, isn't it? So B can't bring anything new alone. Let's see G. Can G bring in something? Yes, G can bring in A. Now you can watch that A and B both are there in the attribute set. I'm again pointing them. A and B both are there in the attribute set. Then we can use this FD. AB brings in CD. Are you understanding? So A and B both together, I am again ticking, A and B both together will bring in C and D, isn't it? I hope you are understanding. Now C has arrived, I am pointing it. C has arrived in this closure. Then C can derive G. So G will come in, but G is already there. G is already there. I am ticking it. Anything else that we can bring in over here, you can see that none of the combinations over here, either BG or AB we have already used, and nothing more can be taken out. Like we have not used this FD, I am marking it. You see, we have used this, I am ticking it. We already used this FD, we have used this FD, we have used this one also, I am ticking it, but we have not used AF derives D. And can we use it? No, we can't, because F is not there currently in the closure set. A is there, but F is not there. So we can't use this. Then can we use this, which I am now encircling? DE derives F. No, D is there in the closure set, but E is not there. So we can't use this. Can you use this? F derives E. I mean, can we pull out E? How can you pull out E? Because F itself is not there. See, the left hand side of this FD itself is not there in the closure set. Then how can you use this FD? And you can't say that E set. What that means is BG plus is going to contain in sequence A, then B, then C, then D, then G. So even B is correct. A was correct. Really, these closures are as given, isn't it? Now let's find out AF plus. AF plus. AF plus will definitely contain A and F. And now, can A alone bring in something? No, never. On the left hand side, we don't have only A. Can F alone bring in something? Check. Yes, F alone can bring in E. Okay. Now, can E alone bring in something? Because E has now got added, but never we have E alone on the left hand side, isn't it? Now, can we bring in anything else, anything new in this, anything more in this? Let's see. Any combination of these keys which are there? Yes, I am encircling this combination AF. You watch. Check where I am marking on the screen. AF together can bring in D. So D has joined. All right. Now, can we bring in anything more? Yes. Check this. D and E together. Check what I am marking. D and E together can bring in F, but F is already there. Okay. Anything else? Any more combination that we can bring in over here? Let's find out. Other dependencies. Can we use AB determines CD? This one which I am marking. No, we can't, because AB both are not there in the closure set. Can we use C determines G? No, because C is not there in the closure set. Okay, can we use this G determines A? No, G is not there in the closure set. That means AF plus is going to contain only AFED. And what's given here is it contains A, C, D, E, F, G. So C is false, isn't it? In fact, AF plus has to be AFED. Okay, so C is false. Although we know the answer, let's confirm by finding fourth option. What will be AB plus? Let's see. What can AB together determine? That's what is the meaning of closure, isn't it? AB can determine AB, and now A alone cannot bring anything new. Why? Because left hand side of any dependency is not A alone. B alone cannot determine anything. Why? Because there is none of the dependencies B is alone on the left hand side. But then let's try, can AB together bring in anything? Yes, from the first dependency which I am taking, CD is brought in. And immediately as CD joins, C alone, check this, C alone is going to bring in G. And as G has arrived, G alone is going to bring in A, but A is already there, isn't it? Now you watch out that these are the keys A, B, C, D, G, isn't it? Can anything else can come in now? Let's watch. Let's find out. Can we use this dependency which I am marking? AF derives D? No, because F isn't there. F isn't there in the closure set yet. Can we use D, E derives F? No, because D and E both are not there in the closure set. Can we use F derives E? No, because F is not there in the closure set. So Basically AB plus is going to contain only these keys. So D is also false. C is also false. Isn't it so? Correct? Then they have asked which one of the following is false. I think in the question, this F was not there. This F was not there. This check the question to get 2006 question. This F was not there, and this was the correct option. Actually, I mistyped it. Sorry for that. I mistyped it. So this is the correct option. A is the correct. B is correct, but C is false. They are asking which one of them is false. Of course, C is false because AF plus is not going to contain so many keys. AF plus is going to contain only few keys. Isn't it so? So C is the correct option as C is false. Thank you very much.